All right, here we go, number 19. 19 is a similar problem to something you've been dealing with, but it's just thrown at you a little bit different. But again, this goes back to Phil Collins, inside out. So what is j of negative 2? But if we look at this, it's really saying when x is negative 2, what is j? In other words, what's y? 8. So this problem turns into the inverse function of h. Once we find it, then we plug in 8. Key, once we find it. So here's h. So that's y equals 2x minus 3. We got to find the inverse function. So we switch the x's and the y's and then solve for y. So I'm going to flip this thing around. Add 3. 2y equals x plus 3. I'm going to divide everything by 2. So y is, I'm going to keep it like this, x plus 3 all over 2. Now, this is no longer y, or h of x. It's the inverse function of h. So now, I know where to plug in the 8, right here. So that'd be 8 plus 3 all over 2. Which is 11 halves, or 5.5. Done. Okay, we're starting the Unit 2 portion of this review, so let's go. I apologize for these little state of Michigan looking periodic functions. Also on your exam review, there's not a 1, there's not a 2, there's not a negative 1. I just put those in there just to make things clear. The problem that's similar to this on your exam is going to be way more clear than this, way clearer. Sorry about that English. But here we go. This is a periodic function. You can just see that it repeats itself, just like the sine and cosine function, but there's a bazillion out there that are considered periodic. But what's the amplitude? Well, the amplitude would be, let me pause this a second. I'm going to draw something in there. Okay, so I basically created a monster here, a disaster. I'm at school, the printer's not available, long story. So we're going to have to do our best with this mess that I've made. So I accidentally drew a line in here. So let's ignore that. Let's concentrate on the pink horizontal line in our attempt to describe amplitude. So what we try to do is kind of cut the graph in half. So half of it's up, half of it's down. This little, and if you notice the peaks, local maximum's 2, minimum's -1/2. So that's 2.5 from up here down to here. And again, I'm looking at the drawing and I'm making general assumptions about it just to keep the numbers workable. So this is 2.5 from here to here. So I take 2.5, divide it by 2, so that's 1.25. So essentially, I have to go down 1.25 and I have to go up from here 1.25. And if that drawing's crazy for you, remember my maximum's 2, minimum's -1/2. If I go up 1.25 from there, I'd end up at 0.75. If I go down 1.25 from 2, I end up at 0.75. And that's why this is my kind of my bisector, my horizontal bisector. So what is the amplitude? 1.25, because it's 1.25 above, 1.25 below. So 1.25 is my amplitude. Sorry about that mess. Period shouldn't be that hard to discern. So you can tell that from 0 to here, that's how long it takes to go through one cycle. We'll just call this 1.75. Just again, your exam problem's not going to be this ambiguous. So it's 1.75, which by the way could be in terms of pi, could be nice whole numbers, but the concept is the same. Domain. Notice this graph starts here and goes this way. Because of that arrow, it's going to go on forever. So my domain, x, is greater than or equal to 0, equal because it does touch there, and then it goes on forever. Range. Now, I said this goes down -1/2. So my range y is greater than or equal to negative 1/2. We'll just assume that it gets there, and then it gets up to 2, and again we're making assumptions that it gets there, but there's the range. All right, there you go. Okay, so we're on to the sinusoids. I'm going to use a pencil because if I screw this up, I got to give myself a chance to start over. So here we go. Graph one period of the following sinusoid. Well, we can see the parent function is going to be y equals sine of x, or theta. I like theta. It represents an angle better for me. And so remember, our parent function, we know this is 1. Sine goes through the origin like so, and it goes up to 1, down to 0, and it says 1 period. And then it reflects the same thing on the other side. So there's 1 period. And so now we got to make the changes little by little. That means reflect. And again, I'm going to use this pencil for the whole journey. And so there's that transformation. Now we've got to double the amplitude on the dotted line. So we're going to go up here. So I'm going to go like this, like this. That negative 1 goes down to negative 2. It just doubles the amplitude. This is going to move it left 45 degrees, which remember it's about that much or that much. So I'm going to take a risk right now and start using some pretty colors. And so that means this spot moves here, this spot moves here, right here, this spot moves here. And once I kind of get the feel for it, I can see this has to move here, and I went a little bit too far down. Forgive me for that, but we're not done. We still need to move that whole thing up 2. So I'm going to look at this spot, move it up 2, move this spot, move it up 2, which is right about here, this spot up 2, this spot up 2, this spot up 2, this spot up 2. So, and I can kind of get the idea here. We're going to be confident and draw it in nice and thick. And there, the pink one is the green one bumped up 2. There we go. Okay, same sort of problem but for cosine. So first of all, we got to realize that the parent function is cosine of x, or theta. And that one, remember, it goes over the origin, and that's the parent function right there. Now we got to make some transformations. So, and it does say find the amplitude, period, domain, and range for this one. So this one's going to be a little bit different. So, and then we're going to have to use our formulas on this one quite a bit too. So, the reason I had this added, actually, you know what? We might be able to do this without the graph, but I might throw it in for free. But let's just check it out. It just says find the amplitude. Well, remember the formula for that is the absolute value of A, which that's A, so that's just going to be 1/2. So that means this thing would actually be more like this. But again, they're not asking us to graph it. I'm just throwing that in for free. Maybe I shouldn't have provided this. The period. Remember the formula, 2 pi all over the absolute value of B. Now B is right here. So that's going to be 2 pi all over 2, which is just pi. So that means these walls come in and it gets shrunk, horizontally shrunk. But they're not asking us to graph it. So our new period is pi. Now, the reason I provided it is this whole idea of domain, maybe we do need it. So you can see I'm flip-flopping all over the place. Now, the original period is 2 pi. You can see this is pi, this is negative pi. And if we go from here to here, we know that's 2 pi. So these walls have to come in. We got to take this one. I'm going to go ahead and make it blue for now. And we got to shrink that thing horizontally. So we're going to go from, this is going to come into here. This is going to come into here. This stays the same, and I'm going to go with the green one now. And there it is. There's 1 period. which is pi. Now what's the domain? Well, this thing goes on forever and ever and ever and ever. So I'm asking for your forgiveness right now. It's asking for the domain of the whole thing. I'm still stuck on this one period. So that little green thing goes on forever and ever and ever in both directions. So the domain is all real numbers. Now the range, though, maybe it is helpful that we have this drawing. You can see it goes up to 1/2, and it goes down to negative 1/2. So that'd be negative 1/2 and positive 1/2. So there's the range. Okay, as your fearless leader, I gotta admit that I almost screwed that up because I didn't even look at this or this. So first of all, the phase shift is C over B. Now remember, because that's plus, it's going to be left C over B. Well, C is pi, B is 2, so I should have moved this green thing to the left, pi over 2. Well, here's the thing. That's not going to change anything about my previous answers. What is going to change it is this right here, down 1. So I'm going to get out an orange marker, and my range is wrong. My orange marker's dying, but this could be the final problem for that wonderful orange marker highlighter. We got to move this all down 1. So this should move here. This at negative 1/2 should go down to negative 1.5, and this negative 1/2 should go down here. And that changes everything about the range, because that would just keep going like this, and this, and this, and this. So now let's talk about the actual new range. Y is greater than or equal to, the lowest point is negative 1.5 now, so negative 1.5, but it's less than or equal to negative 1/2. Almost screwed that one up. But again, the phase shift will not change any of the range, domain, period, or amplitude. So there you go. Okay, so this exam review gives you another shot at these inverse functions. Remember, when it says graph both the function and its inverse, the key to this is knowing that this is a reflection of that over the y equals x line. It's just something you just tuck away and you just know it. So first of all, let's graph this. Well, y equals 3x plus 2. My y-intercept is 2. I need to go up 3 and over 1. 1, 2, 3, 1. And if I do a halfway decent job of drawing this in, let's go ahead and get some colors out here. So there is that. Now, it says find the equation for this, so we got a little extra work to do. Hopefully you're getting good at this. Y equals 3x plus 2. We're going to switch the x's and the y's and then solve for y. So I'm going to subtract 2, subtract 2. I'm going to flip this thing around. Divide by 3, divide by 3. I'm going to rewrite this so it's in y equals mx plus b form. But so that's g of negative 1, or the inverse function of g is 1/3 x minus 2/3. That's what this is if I just wrote it like this, if I reduced it. But this is the same as this. So I don't need this to graph it. All I need is to know that it reflects over the y equals x. So what I'm going to do is I'm just going to take my knowledge of this and do my best just to take this and draw the little reflection. Whoops, boy, that was pretty bad. Okay, and that's all I'm really looking for. But as you can see, if I was to do it with more accuracy, it should have been negative 2/3. So it should have been there somewhere. So really, a more accurate drawing should have been like this. Still not great, but I think you guys get the idea. And then you'd go up 1, right 3, and there you have it. Okay, probably the last problem for this particular video. Explain, using your imaginary triangle, in other words, use this graph, Why tangent of 3 pi over 2 is undefined? Well, remember, tangent is opposite over adjacent. And the only way you can have a fraction be undefined is if the denominator, if the adjacent side equals 0. So we're thinking backwards, but now let's check it out. We take our spinner, draw it here. We got to go 3 times pi over 2, which is the same thing as 3 times 90, which is 270. So we flip it all the way here. Here comes the imaginary triangle part. Technically, it lands right on the y-axis, but then there'd be no triangle. So here's where my spinner kind of, sort of, but not really ends to get our thoughts going. So we realize that at 270 degrees, right here, remember, we're looking, does my adjacent side equal 0? Well, there it is. And that is the side that would disappear at 270 degrees. So that's the explanation. The adjacent side is 0, which would say, hey, can't have a 0 in the denominator. And that's the explanation I'm looking for.